Hey everybody, this is Larry. This is day 6, I think. It's a little bit weird because actually it's October 5th where I am, but I guess today is day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Let me know how everyone's doing. I was actually watching the Yankee game and I kind of missed it, but they're not doing so well right now. Hopefully they'll come back, give me good luck. Wish the team good luck. They should take my good luck, maybe. Anyway, today's poem is find all duplicates in an array. Given an nums of length n, where all the integer nums and one of n, each integer one to choice, return where that appears twice. Okay. I mean, of course, you only want. I think. Well, one is it should be obvious that it should use only constant extra space because. If it's linear space, this is just a dumb. I mean, well, you know, like it's just like a for loop, right? Which there are problems like that on Leetcode, but I guess this is not one of them. The other thing that I am curious about is the thing that I am curious as well about is whether you can use nums itself, because I know that like if you manipulate nums, that's not a great thing. I don't know if that's a possible solution as well, because that would be a little bit awkward. Otherwise, let's see, length is equal to length of nums. And also the other awkward thing is, of course, the output size can be O of n, right? It could be n over 2 exactly. So that's also a very awkward thing. Because by definition that uses O of n space, and it's not, you know, but in a spirit of trying to minimize extra memory, we'll do it. But I think the phrasing has to be really precise, and it was not here. Anyway, yeah, I mean, I don't think there's anything. I mean, the implementation may be a little bit tricky. The thing that I would look up is something called Permutation Cycle, in case you want to do it at home. I'm usually solving these live. Some days I explain it in more detail, some days I don't, and some days I just don't know the good way to explain the solution. But I will give you some reference on how to kind of look it up, because this particular one is I wouldn't say it's mathy in that sense, but there is a lot of good background that a lot of good background math that you can play around with and learn with respect to the permutation cycle. But the idea is just, okay, you know, we swap things so that things are where they should be. I think it's kind of what what I would say. And of course, in this case, we are going to use in place. We're going to manipulate nums, which depending on who you ask, if you ask me, that's not really a good answer, because if I talk about this a lot about API design, but API design is just really like, you know, you basically try to design something that has the least surprise as possible, right? The principle of least surprise. And my question is, if I give a function find duplicates, I give them a list of an array, and suddenly my array memory is all jumbled, I would probably be pretty surprised. So in that case, you know, that's basically the idea there. But anyway, ignoring that apart, the idea here is just going to be to, okay, for example, we go from left to right, we see a 4, then we should swap it with the 7 to make sure that 4 is in the right place. And then in that world, then only one integer will be at each slot unless it appears twice. Then you can kind of, you know, go for it that way. I don't know if I'm explaining that quite well. We can, you know, start by going in the code, but the idea is that, okay, you move the 4 to the slot 4, you move the 7 to the slot 7, the 3 you move to slot 3, and then later on you see this 3 and you're like, oh, there's already a 3 in slot 3, so that means that this 3 is an extra. That's basically the idea. And of course, this is going from 1 to n, so you have to do some one indexing things or whatever you want to call it. But that's basically the idea. I think that's all I have with respect to explanation about this. But I don't know. Yeah, I mean, I think let's get started. Let's get let's start playing with this problem then, right? So now we just go, okay, yeah, left is equal to 0, or maybe we could just go yeah, 4 start in range of n. So this is our starting index. So yeah, so current is equal to start while num sub current. Oh, so wait, okay, this is the index. So the number in the first index is not equal to current, we do something like, okay, now what? Well, let's make the number in the current in current, right? So yeah, so num sub current, we swap it with this, I think, and eventually this should be good, I think. Maybe I'm wrong on this one. Let me think about this. So basically you swap, and then now, this should be okay, but I have to update current. So then, okay, so what happens? So let's say we have, and also we have some off by 1 things, so let's play around with that. But okay, let's just walk through this example, right? So let's say we have here. That's how I do it. Sometimes I do it on, historically, I actually do it on paper, just like write out the examples and kind of go through it. But obviously, I'd want to visualize it for you viewers at home. So that's why I'm kind of thinking about it a little bit. So yeah, let's say is this 0. So this is look at 4. Let me think how I actually want to do this. I'm going to be a little bit lazy because I don't want to think about these indexes and stuff like that. So I'm just going to subtract everything by 1, right? And technically this actually constructs a new list, but we're in the spirit of things. You could just, this is a one-liner. You could have just write for I in range of n, num sub I. Maybe that's a little bit whatever. It doesn't really matter, right? Like we're just playing around with the problem here. The idea, yeah, these things are kind of like, you just try to think about what you want to do and what you want to practice and what you want to learn. For me, I hand wave it and I say it doesn't matter. In an interview, it actually might matter, to be frank. But for me, like, these are trivial fixes, and I'm recognizing them, but I'm just kind of saying it like that. Anyway, yeah. So here now we effectively convert these to an array that's smaller. So 3. Now, what does that mean, right? So current is 0. So while this isn't 0, we swap this with 3. So 6. Okay. So in this case, there can be an infinite loop in the sense that 0 might not be in here, right? Let's replace it with 4. Then this might, this goes to the 6 goes to what is it? 1, 2, 3, 4, 5, 6 goes to the 2, and then the 2 goes to the 1, and then now the 1 goes to the 2, and then here we find the first thing. I'm trying to think a little bit. Does that mean the 0 doesn't exist? I guess that's not the case. Maybe I'm writing this a little bit awkwardly. Yeah, I don't like the way that I'm writing this, actually. Because I think this one has, the way that I'm writing it has more edge cases. So now I'm just trying to think about now I'm just trying to think about what is the right way of doing it, right? So then here, I think we should just follow the current to num sub current. Or maybe, yeah. Right? So then now, for example, we had 3, 2, 1, 6, 7, 1, 2, 0. Then now we swap the 3 of the 6. Oops. Swap this 3 of the 6 But then now, of course, we have to follow this along. So actually, what we want is next is equal to right. And of course, like I said, there will be an addition. Wait, this doesn't make sense either, because that means that 3 is in the right place, right? Okay. Actually, you know what? Maybe that's fine. Maybe what I had before was fine. Actually, we just keep on swapping until we find a dupe. But is that I have the idea, but now I have to think about how to do it quite correctly. So I think there are a lot of like edge cases and stuff like this. Give me a second. You are watching it live, so if you feel like it, feel free to kind of fast forward a little bit. Okay. But yeah, so now we switch to 3. Okay, and then now what do we do? Okay. Because basically here we do the 6, but then now what happens if we have a 2, 1, 2 type thing, right? For example, okay, let's just say we have something like this. Where okay, right? I forget what it was. Something like that, right? I don't know. And then now what happens when we keep going? Okay, the 1, it doesn't do anything. The 2 doesn't do anything. The 3 is in the right place. The 4, we move this 7. So now this is, this is 0. This is 7. And then now we put, the 0 and then we swap the 2. But we already did the 2, right? So that's going to be awkward, because we should not enter it again. Right? Maybe this is fine, actually. Maybe we just don't add until the very end. And then 6, is this on 6 now? This is, because then now in essence, all this does is sorting it. And then now we can just go through all the numbers that don't have it. Okay, maybe I'm happy with that. And then what are the ending conditions of here? So obviously this would be an end condition, but also the other one is if so we keep going until this is the case, or one more thing, right? Which is that if num sub current is equal to num sub current also break. I guess this should be okay. I'm just gonna run it real quick. So we should either get an infinite loop or it'll end, and if it ends, then I'm okay with that. Okay, and then now we can print out the answer. Maybe I should have just added that. That didn't take no effort. Okay, the printing is not good because we print the answer. What we wanted to do is actually print the nums away, because here now everything should be sorted except for the things that are out of order, right? So yeah, so as we expected, so now we have the 2 and the 1, so then that should be good. I mean, of course we have to add back 1, but that's fine. So now we do for I in range of n, if num sub I is not I, n start append I plus 1, and then we just return answer, right? Oh, dong dong dong. Really? Did I misread something? Let's take a look again. 0, 1, 2. Num sub I is not equal to I. Yeah. Oh, I'm returning the index, not num sub I. Whoops. Okay, so we are maybe still okay in concept. I think the harder part is going to be to show that this is linear. Oh, look, I've done this a year ago. Which I will show in a second if this goes. Look, we're another 1 day streak. A little bit slower this time. I'm just curious. What did I do a year ago? I don't remember this problem. I just remember the concept. I don't really, and in general, I don't really remember problems unless I'm learning something from it. But okay, wow, I did it some other way. I think, well, I mean, I did it the same way, but in a different concept, maybe. No, I think we mostly did the same, but different code. But yeah, so okay, so the hard part is kind of thinking about how many operations this take, right? How do you analyze the complexity? Well, in this case, let's just skip this because this is O of n, this is O of n, and this is O of, technically, like I said, O of n space, but what? But this is O of n space, but O of one extra space, because this is, I don't know, depending on how you want to say extra, but because, you know, we only have variables things, and of course we can also do another for loop to fix the input if you like, but we already messed up the input anyway. No. You do the math here. But yeah, so the way that I would think about how to analyze this complexity, the naive thing to say is that this is an O of n loop, this can go O of n times, so this is n squared time, right? But that's not the case, because this is, I don't know what n is. N is 10 to the 5th, so if it's n squared, you're going to get time limit exceeded anyway. So the reason why this is n is you can think about each number that's in this array, right? In a way, we're kind of like sorting it. It's not really a sort per se, but you can look at every element in this array and ask yourself, what's the most number of swaps that you can get, right? Well, every swap means that one number is put into the right place, right? And if that's the case, that means that there will be at most n swaps, meaning that there will be n swaps, or n minus 1 swaps, sorry, off by 1. N minus 1 swaps if every number appear once and you swap them into the good place, right? Because every swap, like the invariant is that every swap means that one number is in the correct place. So that means that you have n minus 1 swap at most, and because you have n minus 1 swap at most, that means that this is going to be at most O of n times, together, combined, amortized, however you want to say it. So the sum of all the individual swaps is going to be O of n. So that means that this is only going to happen O of n times, and that means that the total amount of complexity is going to be O of n. Yeah. And of course, O of one space, blah, blah, blah. We already talked about it earlier, so I'm not going to go over it that deeply again. But yeah, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and wish me and my Yankees good luck. Anyway, I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.